So we are going to, so for next 25 days, we are going to concentrate on Postgres database administration. And these are the content that we are going to cover for the next 25 days. And myself, my name is Hari Krishna, and I have like 7+ years of experience in the field of Postgres database administration, and I'm a working professional. Okay. So for the first thing, we are going to discuss about what is Postgres and what is the architecture, and this entire Postgres architecture we are going to divide into three parts. One is a general purpose architecture, memory based architecture, and process based architecture. And the memory based architecture is having some subcomponents, and process based architecture is going to have some subcomponents. We are going to uh, have a detailed discussion about each and every component. For completing this Postgres architecture, I'm going to take like 3 to 4 classes. And next, we are going to discuss about the important supervisor process called postmaster process in Postgres as well. Once that is done, we are going to discuss about the Postgres database installation to install the Postgres database. Okay, so we have to have an environment in our personal laptop. To set this environment, we are going to install the VMware in your personal machine, and on top of that we are going to install the Linux. Once that is done, we are going to perform a Postgres installation. Post installation, we are going to see what are all the cluster operations that we have, and what are the different directory structures that we have in Postgres, and how can we connect to the Postgres database. And we are also going to see what is host based authentication in Postgres. Okay, the next thing we are going to discuss is we are going to discuss about the various management techniques, like how can we manage a parameter file, and how can we manage a database, how can we manage a table space, how can we manage schemas in Postgres, and what is a user and role, how can we manage the privileges, what is the concepts of vacuum, auto vacuum in Postgres, and how it is going to affect the query performance. And also we are going to see about the archive log mode in Postgres, and what are the steps that are involved to enable the archive log mode in Postgres. And this slide are the advanced topics of Postgres database administration, where we are going to see the backups and recovery scenarios. So we are going to see about, like the Postgres logical backups, how can we take the backup and how can we restore, and what are the different options that are available to take the backup of a schema, table, and database, and how can we take the backup of users and roles. And we are also going to discuss about a physical backing up utility called pg underscore base backup. Okay, and we are going to discuss about the replication. In the replication, we have a streaming replication, logical replication, and we are going to see about the what are the types of replications that we have, and how can we configure the streaming replication, how standby is going to get recovered when there is a val file missing. And we are going to see how the upgradation methods, and we are also going to see some basic stuff about multi-version concurrency control, basic performance tuning, extensions, and basic queries that are needed for a Postgres DBA. So these are all the topics that we are going to cover for next 25 days from today. Okay, so to start with, so why Postgres? Okay, so we have a traditional database management systems like Oracle, like SQL Server, and we do have a DB2, and we do have some like SQL Server, DB2, and all those things are there. But why Postgres? Why Postgres suddenly came into a limelight, right? So when you take Oracle as an example or SQL Server as an example, you need to pay. So let's say you wanted to install Oracle database in your organization, you need to pay some license. Okay, you need to pay some licensing to the Oracle Corporation. So if you are going to install SQL Server, you need to pay some license to the Microsoft. Likewise, Postgres is a open source database. Okay, Postgres is a open source database. There is no need to pay anything. A single penny is not required to pay to any of the organization. So we can directly download the software from the the from postgresql.org, and you can try installing it in your system, and then you can use it as a database to store your application specific data. Do we need to pay anything? It's not required to pay anything. But what are the advantages and disadvantages of having a open source database, right? So let's say you are working on an Oracle system and you had some issues, then you have a feasibility of okay, raising a Oracle SR service request with the Oracle Corporation, so that someone from the Oracle company will get in touch with you and they'll try to resolve your issues, right? But so if it is a SQL server, then someone from Microsoft engineers will get in touch with you to assist you on the issues that you are facing. Okay, then so in case of Postgres, as Postgres is a open source, if something goes wrong, if you're not able to solve something, there will be no support from the Postgres side. When I say there will be no support, we do have some third party tools which are there to support the open source Postgres, but from the Postgres community we don't get any support because we are not paying a single penny to the Postgres community. So, so by using this as an advantage, some people has taken. So as Postgres is a open source, you can get the source code from the internet directly. So a company called EDB. So a company called EDB has taken this source code from the internet. Okay, taken this source code from the internet and they have added some other options. Okay, they have taken source code from the internet and they have added some other options. Okay, and they released it as a EDB Postgres. They released it as a EDB Postgres. So EDB Postgres means EDB is a company where they have taken Postgres source code and they added some other options and they released it as EDB Postgres. When you go and install EDB Postgres, you will be getting a support from the EDB team, but you need to pay the licensing. Okay, but you need to pay the licensing. So this is briefly about the Postgres system. So why Postgres is popular now? Because of due to no licensing. So people are willing to, as a cost reduction or cost optimization, people are willing to choose Postgres. Okay, for the areas which they think it's not that much let's say if it is there is an ICICI bank, they cannot directly go and implement the Postgres database to store their data because it is a financial consulting. If something goes wrong with the Postgres, they have to end up paying huge penalties to the government or people. So but where they can use this Postgres, so let's say there is a database which stores customers data. I mean to say, when I say customers data, it is not about the actual ICICI bank customers. So we do daily get a calls from the ICICI bank to for offering credit cards, for offering loans and all, right? If we lose that data also, there will be no such impact. So that kind of modules that where we can store it in the Postgres database to avoid the high licensing cost that we are paying to Oracle. Okay, so now without having much delay, we are going to discuss about the architecture of a Postgres. So we divide this entire Postgres architecture into three parts. One is a general purpose architecture, and second one is a memory based architecture, and third one is a process based architecture. So first next three class we will be discussing briefly about this architecture method or architecture of a Postgres, and it will be kind of boring, but believe me, once this is done, if you have thorough understanding of the Postgres architecture, it will be very easy for you to understand the things. Okay, so the entire Postgres architecture we are going to divide into general purpose architecture, memory based architecture, and process based architecture. So now let's start discussing about the general purpose architecture. Okay. The general purpose architecture is common for all the database. Either you can take Oracle, you can take Postgres, MySQL, DB2, SQL Server, you take anything. This general purpose architecture is one and the same. So like any other RDBMS, Postgres also works on a client server model. Okay. Like any other RDBMS, Postgres also works on a client server model. What is the client server model? So let's say this is a client, he is going to send a request. So this is a Postgres database. Client is going to send a request, server is going to accept the request, and server is going to process the request, and it is going to send a response back to the client. Okay. So like any other RDBMS system, either you can take Oracle or you can take SQL Server, you can take a DB2. Every database will work in the same model, like how the how the client server model works. So where as a client I'm going to send a request. Let's say I'm going to do select start from EMP. When then the database has to accept the connection, database has to process the request, and it has to give the response back to the client, right? This we call it as a client server model. So in general purpose architecture is very pretty simple to understand. So as I said, Postgres works on a client server model. So to send a request to the client, okay, to send a request to the server, what are all the tools that are available? So general purpose architecture talks about, okay, general purpose architecture talks about what are all the different tools that are available in market to interact with the Postgres database. Okay, general purpose architecture talks about what are all the client tools that are available in the market to deal or to talk with Postgres database. Let's say I have a Postgres database which is running on 192.168.29.30. How a client or how an application can interact or can talk with the Postgres database. So what are the tools that are available in the market that we are going to discuss in general purpose architecture? Okay, so based on the type of a tool, we divide the tools into three parts. One is the GUI based tools, and second one is a CLI tools, CLI command line interface, and third one is a app servers. As a DBA, are we going to talk about app servers? Do we need to know about the app servers? It's not required because it's not our cup of coffee. Because as a DBA, we will not be maintaining the app servers. It is the responsibility of the application teams to manage the app servers. But through app server also we can talk to Postgres database. So what are the GUI based tools that we have? We have PG admin, we have DB waiver, we have Pentahio, and we have DB Xolo. So these are the different graphical user interface tools that are available in market. Okay, these are all the different graphical user interface tools that are available in market. Okay, to interact or to talk with the Postgres database. So among them, DB Weaver, Pentahio, and DB Xolo, these are all the licensed tools. Okay, and this is a PG admin is a freeware. And do we use this PG admin or do we use the GUI based tools to perform the database administration stuff? Obviously, no. But we do have an option to perform the database administration activities using GUI based tools. But I would not recommend you to take this option because with a single clicks you can take a backup. With a single click you can take a restore. With a single click you can create a user and no need to write the syntax as well. So it is similar to SSMS which we have in SQL Server and SQL Developer which we have in for Oracle. So GUI based tools we don't recommend you to use, and these GUI based tools will be used by the developers to develop procedures, functions, kind of things. Okay, so coming to the command line interface, in Oracle we have a SQL Star Plus which we will use to connect to the database. Likewise, for Postgres we have a tool called PSQL. So PSQL is a command line interface which we have for Postgres to interact with the Postgres database. So how can we use this PSQL and how can we connect to the Postgres database and all those things, this we will be discussing it in the next classes. Okay, so coming to the app servers, we will be having different app servers like Apache Tomcat, we have JBoss, and we have WebLogic. These are the different app servers that we have. So but do we really care about these app servers as a DBA? No, it's not required. So our concentration would be, okay, our concentration would be more into, like the command line interface. Whatever the discussion that we are going to do for the next 25 classes, what are the things that we are going to do for the next 25 class, I will be showing it in the PSQL. But in one class I'm going to show you how can we use PG admin to connect to the Postgres database. It is simple only because this is a GUI based tools. It will ask you for the host name, port number, username and password. Once the moment you will give it, it will connect to the Postgres database. That is a separate topic altogether. Okay, so this general purpose architecture, so it explains, okay, so what are the different types of tools that are available in the market to connect with the Postgres database, and based on the availability we divide it into three parts. One is a graphical user interface tools, CLI and app servers. So the next architecture that we are going to discuss is, we are going to discuss about the memory based architecture of Postgres. This is very 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 important. Okay, so this entire memory based architecture is divided into two parts. One is a, so when I say memory, it is a RAM, it is not a disk. Okay, when I say memory, it is RAM, it's not a disk. So this entire memory based architecture is divided into two parts. One is a shared memory areas, second one is a local memory areas. So one is a shared memory areas and second one is a local memory area. Okay, shared memory area means, shared memory area is a memory area which is accessed by all the background process in Postgres. Okay, shared memory area is a memory area which is accessed by all background processes in Postgres. So this is a common memory area which can be accessed by all the background processes that we have in Postgres. Okay, that we have in Postgres. So there is no restriction. What are the processes that we have in Postgres? Those have access to this memory area. Then what is the local memory area? So local memory area means each and every process. Okay, each and every process will be assigned with, each and every process will be assigned with some amount of memory which is private to the process, which means no one can access to that memory area. Okay, so each and every process will be assigned with some amount of memory which is private to the process or which is local to the process, and that is not accessible to the other background process. Okay, so what is the difference between shared memory areas and local memory areas? A memory area which is accessed by all the background process is called as a shared memory area, and a local memory area means it is a private to the process or it is a local to the process, and no other process can see the memory that is allocated to a particular process. It is per process. Okay, it is per process, and each memory component having some sub components. Okay, So now we will see them. Okay, shared memory areas. So what are the different components of shared memory area? We have a shared buffers. We have val buffers, and we have clock buffers as well. We have shared buffers, we have val buffers, and we have clock buffers. What are the local memory components? We have work memory, we have temporary buffers, we have auto vacuum work memory, and we have maintenance work memory. Okay. So they are the local memory component. We have work memory, we have temporary buffers, we have auto vacuum work memory, and we have maintenance work memory. Okay. The shared memory areas are shared buffers, val buffers, and clock buffers. And local memory areas are work memory, temporary buffers, auto vacuum work memory, and maintenance work memory. So now we will start discussing about one by one. So the first thing that we are going to discuss is a shared buffers. Okay. Okay. So this is what? This is a RAM based memory area. So whatever the amount of memory that we are allocating to the shared buffer, that will be taken from home, that will be taken from the RAM. Okay, this is a RAM based memory area. Okay. So how can we define the size of this memory area? Is there is a concept of parameters which we are going to discuss in the parameter file management. There we will see how can we change the parameters and how can we see the parameter values and all. So for now, shared underscore buffers is the parameter. Okay. And what is the default value? 128 MB is the default value. Okay, 128 MB is the default value. Okay. And so now what actually this and what is that recommended value? The recommended value is 25% of the system RAM. Do we need to tell all these things during the interview? No. So you need to focus more on this only. So you need to no need to tell about the default value, recommended value, and all those things. But for our understanding purpose, I'm keeping it here. So now let's discuss about what is shared buffers. Okay. So let's say I have a Postgres database which is running on some server called 192.168.29.130. I have a client sitting somewhere and he's trying to query this Postgres database, and what he wanted to get, he wanted to get a select star from test. Test is the table name from which he's trying to get the data. So what happens whenever client sends a request, what happens, right? First it will go and check whether the requested data is available in the shared buffer or not. Okay, whether the requested data is available in the shared buffer or not. If the requested data is available on the shared buffer, then we call it as then we call that mechanism as a catch a hit. What is catch a hit? Whenever client sends a request, if the requested data is available in the shared buffer, then we call it as a catch a hit. So what happens when in case of catch I hit? So shared buffer is a RAM based memory area, right? So whenever the system finds the requested data in the shared buffer, the data will be given back directly to the client. Okay. So whenever client sends a request, if the requested data is available, then we call it as a catch a hit. In case of catch a hit, the data will be directly given back to the client. So what is the other scenario? Whatever the data that client is looking for, that data is not available on the shared buffer, then we call it as a catch a miss. Okay, then we call it as a catch a miss. What happens in case of catch a miss? In case of catch a miss, the Postgres process has to go to disk, fetch the data. Okay, it has to go to disk, fetch the data, keep the data back in the shared buffer. From the shared buffer it has to give the result back to the client. Okay, from the shared buffer it has to give the result back to the client. So in case of catch a hit, number of IO operation is only one. From the buffer it is going to give the result back to the client. In case of catch a miss, there are two IOs for each operation. One is it has to go to disk, it has to scan for the requested data, and that data it needs to keep it back in the shared buffer, and from the shared buffer it has to give the result back to the client. Number of IO operations are increasing, and one more point is getting a data from the memory is faster or getting a data from the disk is faster. Which one is faster? Is getting the data from the memory is faster or is getting the data from the disk is faster? Always getting the data from the memory is faster. So in case of catch a hit, the query execution time will get decreases and the performance of a query will get increases. In case of catch a miss, as number of IO operations are getting increased, the query execution time increases, which means eventually the performance of a query is going to get decreases. So this is about catch a hit and catch a miss. When someone asks you about the shared buffer, you need to talk about this mechanism called catch a hit and catch a miss. So the next is shared buffer. Okay, shared buffer also holds a data called dirty data. Shared buffer holds what data? Dirty data. Okay, shared buffer holds dirty data. What is dirty data? Dirty data is a data. Okay, so before explaining about the dirty data, so we are going to see something about what is dirty data. Okay, let's say I'm a client which is connected to the Postgres database. Okay, which is connected to the Postgres database, and I perform some operation called update emp set sal equal to sal plus 100, where employee number equal to 101. So for the employee 101, what I have done? I have increased the salary by 100 rupees. Okay. So if it has to perform, okay, if it has to perform this update operation, the data should be in which location? The data should be in shared buffer location. Okay. So whenever you fire this command again, it will go and check whatever the data that needs to be updated is available in the shared buffer or not. If it is available, then it is going to perform the update operation. If it is not available, then it has to go to disk, keep the data back to the shared buffer, and from the shared buffer it has to perform the update operation. Let's say what happens, right? Whatever the data that it is going to update, that is not available on the shared buffer. So in the EMP table for the 101 employee, the salary is 2000. Okay. So when you are going to update, this should go to which location? Shared buffer. Right? From the shared buffer after update, what is the value? 101 and 2100. 101 is the employee number and 2100 is the updated salary. Where we have this updated salary? We have this updated salary in the shared buffer. Okay. But so what is this dirty data, right? Dirty data is a data. In the disk, what is the value that we have? In the disk, I have 101 and the old value 2000, right? So what is dirty data? Means dirty data is a data which is modified, okay, which is modified but not yet written to the disk. We call it as a dirty data. So what is dirty data? Dirty data is a data which is modified but not yet written to the disk. So who is going to write this dirty data from shared buffer to the disk? There is a special process called background writer. BG writer is a process which is responsible for writing this dirty data from shared buffer to the disk on the event of commit or checkpoint. Okay, so background writer is a process which is responsible for writing this dirty data from shared buffer to the disk on the event of commit or checkpoint. So what is shared buffer? Shared buffer is a RAM based memory area. So whenever client sends any request, so it is going to go and check whether the requested data is available in the shared buffer or not. If the requested data is available, then we call it as a cache hit. If the requested data is not available, then we call it as a cache miss. In case of cache hit, the data from the shared buffer will be given back to the client. And in case of cache miss, it has to go to disk, fetch the data and keep the data back in the shared buffer, and from the shared buffer it has to give the result back to the client. Shared buffer also holds a dirty data. What is dirty data? Dirty data is a data which is modified but not yet written to the disk, and background writer is a process which is responsible for writing this dirty data from shared buffer to the disk on the event of commit or checkpointing. So the next memory, so any doubts so far? Any doubts so far?
Yeah, hi. Is this recording? Actually, I joined
Yeah,
late.
yeah, yeah. This is getting recorded. I'll be sharing. That's not an issue.
Yeah, yeah.
Any doubts so far? If not, then I'll proceed with the next things. Okay. So the next memory area that we are going to discuss is we are going to discuss about the clock buffers. So what is a clock buffers? So for the shared buffers, we have a parameter called shared underscore buffers. Likewise, we don't have any specific parameter to maintain this memory area. We don't have any specific parameter to maintain this memory area, and clock buffer is a memory area which is going to store the state of the transaction, which is going to store the state of the transaction. Okay, so the state of the transaction can be what? In progress, committed, subcommitted, aborted, like that. Okay, and do we have, as a DBA, do we have any control over this memory area? No, because we don't have any specific parameter to maintain this memory area. So the Postgres is internally going to maintain. Postgres is going to maintain this memory area in tiny amounts. Postgres is going to maintain this memory area in very very tiny amounts, and we don't have any such control to increase or decrease this memory area. So this is about the clock buffers, and no one will ask you about clock buffers because this is not something which we are going to handle as a DBA. So the Postgres is going to maintain this memory area internally. So just I'm stopping it for today because on the first itself I don't want to go deeper into that. In the next class, so we are going to discuss about the remaining memory areas which is called val buffer. Okay, we are going to discuss about the val buffers, and we are going to discuss about some of the local memory components in the next class. So that's it for today, and we'll connect tomorrow. And in some time I'm going to upload this recording into one of the shared drive, and I'll be giving you the access for the same. Okay, Any doubts so far? If not, just we'll wind up the session for today and we'll connect tomorrow.
Yeah, here actually there are some people don't know any DBAs before any. We don't have any Oracle also. So will it possible to teach from scratch level from beginning?
This is the
When they don't know
scratch.
the terms like yeah, yeah.
So see, I mean, yeah, terms means what? I mean, yeah, tell me just. That's okay.
Means naming terms means we do, first time they are listening those namings. So first will
What is? I mean, I don't understand. What is the naming term means?
Means what
means
is
we
database?
don't
Why
know
do we
right.
use it? What is client? So the basic
Upper
ideas we need
catchy.
to get it.
Okay.
Yeah, as an Oracle DBA, I know what is database and what is client and all these things. But the very basic person that doesn't even know what are all these terms. So if you go from scratch, they'll get an idea.
So this is the see for the DBA. See, I'll tell you one thing. I thought like everyone is a DBA here. So for the DBA, the prerequisite is you need to know the basic select command. Okay, and you need to know the basics of Linux. This is the prerequisite to to start the Postgres database administration course, where I'm not going to teach about the Linux commands and I'm not going to teach the basic select statement. So if you need, just I can give you the reference from where we can go and we can check. So how many of you are not from doesn't know about this basic select statement and basic commands of Unix?
Uh, Hello, hi. Actually, I work, uh, particularly, I don't know anything in background of select of database anything because I work as an IT operation system administrator.
Okay.
So, and this is first time I'm listening this course.
Mm-hmm.
Yeah. So, yeah, I have some basic knowledge on Linux. Actually, I did an course on
Okay,
Linux Red
so
Hat
see, basics of
system
Linux,
administrator.
if you know, just I'll be giving you
Yeah.
some YouTube videos. So basic select means the select statement is going to get the data from the table. Okay, so that exercise you need to do from your end, Shiva. I mean, will you be able to do that? Just go through YouTube videos and check. If you need any help, that I can help you.
Okay.
So, but the basic things like how to retrieve the data from a table and all those things that you need to do some work from your end actually.
Yeah, I think directly I can't jump into the Postgres, right? I need to know what is SQL and basics of, this foundation fundamentals of SQL and all things.
I won't say like you need all that. I mean to say like things about the Postgres.